This is another numerical. A capacitor of 10 microfarad is connected between the points P and Q. Between points P and Q of the following circuit. Calculate energy stored by the capacitor in steady state condition. Here is the connection. We want to find out the energy stored by the capacitor in steady state condition. Okay. So first of all, what is the energy stored by capacitor? We know that energy stored by capacitor is equal to half C V square. C is the capacitance value, V is the potential difference across it. Okay. Here you look at the circuit. Here capacitance value is given 10 microfarad, but potential difference is not given. We have to find out the potential difference between P and Q. Okay. So to determine the potential difference between P and Q, you have to first find out what is the potential at P and what is potential at Q. Okay. Then you have to find out the difference between the potentials. So to find out the potential at this and this, what is the role of capacitor in this circuit? First we have to determine it. What is the role? Now in the steady state, that means finally, we do not know that whenever capacitor is connected through a DC, of course it gets charged, and once it gets charged, it is open circuited. Okay. Once capacitor gets charged, it becomes open circuited. So it is open means no current is flowing between P and Q in the steady state. Got my point? In the steady state means final state. That means whenever the circuit is working steadily, no changes are there. Substantial changes are observed in the circuit. In that condition, capacitor will be allowing no current through it. Okay, it will act simply as an open circuit. So since we are dealing with the steady state conditions, we can simply replace this capacitor with an open circuit. Okay, let us draw the circuit again. 24 volt. This is 5 ohm. This is 3 ohm. This point is P, this point is Q, and I have just replaced the capacitor with open circuit. 3. This is again 5, and this is the connection. Okay. Now what is the potential at this point and potential at this point? Let the potential at this point be Vp and potential at this point be Vq. Okay. So to determine the potential at this point, we have to first determine what is the current through these resistors. Then we can only determine. So to get the current through the circuit, first draw the equivalent resistance of this total circuit. Here 5, here 3, 3, 5. Okay. Now total current entering here will get divided here or not. Okay. This is total current I. It is getting divided here. One part goes through 5-3 and another part goes through 5-3 also. Okay. Now if we find out the total equivalent resistance of this sub circuit, you look, current getting divided here, that means this part is in parallel with this part, but same current goes through this 5 and 3 and here 3, 5. One current, a single current flows through this 5, 3, 5 and another current flows through this 5, 3. That means these 5, 3 are in series, these 3, 5 are also in series. So series means 5 plus 3, 8. Here it is also 5 plus 3, 8. So 8, 8. So in the new circuit, this is 24, 8, 8, Okay. Now this is the total current I. Okay. Now 8 are in parallel, so total resistance, equivalent resistance will become, let me again draw this, 24. Equivalent resistance of 8 parallel is 4. So total resistance is 4. Now total current I is nothing but 24 by 4 is equal to 6 ampere. Okay, by Ohm's law. So 6 ampere is the total current flowing through this circuit. Now this is 6 ampere. Okay. Now this 6 ampere, you can see this is 6 ampere. So this 6 ampere again is getting divided here through these 2 8s. Of course same resistances are there, means 3 ampere will be going through this path and 3 ampere will be going through this path. 3 ampere, 3 ampere. Okay. Now come to this part. This is 3 ampere. This is also 3 ampere. So here you look, 3 ampere goes through 5 as well as through 3. So here it is 24 volt. This point is having a potential of 24 volt. Since this is negative terminal, so this point will be having a potential of 0 volt. That means here it is 24 volt, here it is 0 volt. So this part only drops 24 volt. Okay. Now we want to find out Vp. Okay, we want to find out Vp. So how to find it? 24 minus this drop is equal to Vp. Again, here it is 24 volt, 1 drop through 5 ohm resistance and it becomes Vp. So how to write it? 24 minus this drop is equal to Vp. What is this drop? Drop means voltage drop, that is resistance into current, that is 15 volt. 24 minus 15 is equal to Vp. 24 minus 15 is equal to Vp is equal to 9 volt. Okay, this is equation 1. We have already got the Vp value. Similarly, what is the value of Vq? 24 minus this drop is equal to Vq. This drop is nothing but 3 into 3, 9 volt. So 24 minus 9 is equal to Vq. 24 minus 9 volt is equal to Vq is equal to 24 minus 9, that is 15 volt. This is equation 2. Okay. We have to find out the potential difference between Vp and Vq, that means Vp minus Vq. So Vp minus Vq is equal to 9 minus 15, that is minus 6 volt. Okay, this is nothing but V, that is potential difference across the capacitor, because capacitor is connected between P and Q. So energy stored in capacitor is equal to half C V square is equal to half. C value is given in the question, that is 10 microfarad. So 10 into 10 to the power minus 6 into V square. V is minus 6. So minus 6 square. This is equal to, this is 5, this is 36. 36 into 5, 36 into 5 into 10 to the power minus 6. If you take 2 from this 36, it will become 10 to the power minus 5. If you take 2 from this 36, it will become 18. 2 into 5, 10. 10 into 10 to the power minus 6. 10 to the power minus 5 joule. 18 into 10 to the power minus 5 joule. Got? This is the answer for this question. Very good question. Okay, in the next class we shall move on to the next topic. Thank you.